Hi, I'm Mr. Orr, and we are now looking at section 7.3 in your textbooks. This is rotations. A rotation, you may recall from the first section here, if I took that letter F and I had attached it by a string or something to a point down here, and then I rotated it, let's see if this will show up well enough, I rotate it 90 degrees. All right, the rotation has turned it, and in this case, it's turned it 90 degrees clockwise. Because remember, clockwise goes around to the right, except for those of you who have looked at my backwards clock, which goes around to the left. Now, a counterclockwise rotation would take it this way, and I'm not sure I can do this. It would be like that. Now that would be, let's see, I really need to bring this up a little bit to make it look, and maybe not make it quite so large. Let's see, that's about right. And then it would go this way, and then actually, I think I had that wrong. It would go this way. There we go. All right, so it should probably be in a little bit further, but this then would be a counterclockwise rotation of 90 degrees. Okay, so clockwise rotation, counterclockwise rotation. It's not a flip, but as you'll see in a moment, they are related. So the center of rotation is the point on which it's connected, these figures are connected to this wire, or imaginary wire, so that we have some point to measure from our angle. So if this is the point of rotation, or the center of rotation, then we know that this then would be a 90-degree rotation clockwise. And that would be the angle of rotation. Now, as we move through this section, a rotation is an isometry, and you will recall that an isometry is a transformation that preserves size and shape. All right, now, see if I can actually draw this here. If you have a reflection followed by another reflection, you actually end up with a rotation. And let me see if I can show you how that works. If I draw two, I'm going to move this out of the way. If I draw two intersecting lines, here, let's say, and here. Now, over here, let's say I have line A, line segment A, B. Let's call this line K and this line L. Okay, the first thing I'm going to do is reflect that thing across, let's move that a little bit, across K. So this comes down here, this is, now, these symbols are referred to as primes, and that's different from prime numbers. But what this is saying is, if the original one was AB, then the reflection over here is A prime, B prime, and this simply distinguishes this AB from this AB. All right, now I want to take that and I want to do the same thing with it, but I want to reflect it down here like this. Okay, now this should be double prime. Okay, the first reflection you get to A prime, B prime. The second one you get to A double prime, B double prime. But notice what's happened here. This B reflected across close to the line, and this A reflected across far away from the line. So in fact, this thing has now done a flip and then a flip again. Now if you will look, and if you can imagine, this one turning, now pretend you don't have this in the middle, it turned or rotated around here so that this A came around to here, and this B came around to here. Okay, so it's now upside down looking from where it started. But in fact, that's a rotation. So I put together two flips or two reflections, and I get a rotation. Now that rotation, the angle of that rotation, is going to be twice the angle that is formed right here between the two lines that we flipped over. So that was K. I lost part of my K up here. That was K and L. So there is an angle here formed by lines K and line L. I reflected across K, then I reflected across L, and I ended up with a rotation, and the angle of rotation is twice the measure of this angle. All right? A figure has rotational symmetry. You remember the previous section in which we had lines of symmetry. Now, a figure has rotational symmetry if I can rotate it and have it fit onto itself. So, for example, let me see if I can show you a good example here. If I take, let's see, so 180 degrees or less, a square has rotational symmetry because it maps onto itself by a rotation of 90 degrees. So let's take a square here. If I turn this square 90 degrees, that means this side is going to move to here, this side moves to here, this one to here, and this one to here. And I've turned it. Now let's see if we can see how that would work. If I make one of these lines blue, okay, and here's the blue line. Now I'm going to redraw it as a 90-degree rotation. Here's my square again. But now, because I turned it 90 degrees, this is now where the blue line ended up. And I'm only doing this so that you can kind of see what's happening with this. Now, 90-degree rotation took this around to here. Another 90 would be to here, another 90 to here, and another 90 to here, and that totals 360. So that has 90-degree rotational symmetry. And you will get into some that are a bit more complicated as you work through this section. Keep in mind that you can rotate any number of degrees clockwise, this way, or counterclockwise, this way. Now, ordinarily, we're going to be dealing only with 45, 90, 180, and at least for this section. So they're not real complicated, but in some cases, they're a little bit difficult to see. You'll have to take a minute and really kind of study the figure to see what's going on. Okay, and that concludes our section 7.3 lesson. Thank you.